Good evening, class QNT 3890. As you know, class has been canceled today. Obviously, you know that by now. I'm going to make a little video here about some of the things that I wanted to cover this evening, which is January 9th, 2018. The reading was for chapters 1 and 2. Chapter 3 we're going to discuss later on, out of sequence in the book. We'll be returning to discuss ethics later. So chapter 1 and 2, I looked at both the 13th edition and the 11th edition, which are the editions I have, and I had requested that you get the 12th edition. So the 11th and the 13th are very similar in chapters 1 and 2. I'm hoping that the 12th edition is similar as well. At any rate, perhaps you can get an idea about what we were talking about, or what was in those chapters, if it varies from what goes on in this video. I'm ad-libbing this without an awful lot of prep. You know that I start every class with a guided mindful meditation. Guided mindful meditation has 3 parts at least that I like to point out. One is resonant breathing, and I do that with the assistance of the Do As One website, choosing 6 breaths per minute, which means 1 breath every complete one complete breath, inhale and end of to the end of the exhale every 10 seconds, which works for most people. There are physiological reasons for choosing that length of breath. Besides resonant breathing, I use Imagery, and the Imagery is designed to occupy your processor. Our brains, our computers, they have a limited capacity for processing information. By putting lots of varied imagery in front of your mind's eye, so to speak, for instance, things that refer to touch and sight and sound and smell and taste sometimes as well. The idea is to maximize the processor by utilizing imagined input from various sensory modalities in an effort to max out the processor, not leaving enough room for the what I call left hemisphere chatter that goes on in our heads all the time. What are we going to do for dinner? Who's going to pick up the kids tomorrow evening after school? That kind of stuff. So the other is narrow focus, trying to get you to focus narrowly on the imaging that I'm presenting, or when doing a body scan, focusing on various body parts. All 3 of these things are involved in a guided mindful meditation. The way I do it, there's lots and lots of ways to do it. My way is just my own way of presenting it, and I do find it to be quite effective with a lot of people. We have a class research project. One of your jobs is going to be one of your assignments is going to be to write a research report in APA style. You're going to have to identify certain aspects of our research and make a few comments about them. Our class research project is one that I have imposed upon you. My hypothesis is basically this, that sessions of guided mindful meditation before class will result in an improvement in short-term memory. Now, making a hypothesis like that, just the way it is written or spoken the way I just did, is not testable, because there's not enough specific information. Variables, the independent variable, which is the one that is manipulated in an experimental research project, and the dependent variable, wherein you measure the results of your intervention, have to be very clearly operationally defined. So to define guided mindful meditation operationally, we could simply say guided mindful meditation as done by Dr. John Galaska, including resonant breathing, imagery, and narrow focus, would be one way of operationalizing it. A more specific way would be to take videos of each of my guided mindful meditations before class, so that if someone wanted to reproduce this research later, they could take those videos and perhaps use them, which would be better than having different clinicians try to do guided mindful meditation in the same way I do. The hypothesis has to be testable. So the guided mindful meditation is the intervention. That is the independent variable. That is the one that we manipulate. We either have guided mindful meditation or we don't. In this case, we don't have a control group. We are looking to see differences in the dependent variable within our subjects, which happen to be you. And you happen to be a convenience sample. You are assigned to this class, and so we conveniently are using you as our research sample. Now, there's lots of problems with that. We'll be talking about the selection of a sample later, but the biggest problem is whether or not the sample is representative of the group to which you would like to generalize your findings. Generalization is also referred to as external validity. Now, if I want to generalize my hypothesis to all of Antioch's students, I would need to have a much more representative sample than the convenience sample that we have here. So we have a methodological problem in this class research project. So I'm calling it a mock research project. Identifying the weaknesses of this will help you understand what should be involved in an actual research project. So, independent variable, guided mindful meditation. That is the one that we are manipulating. The dependent variable is short-term memory, and we have to operationally define that. That can be done using the instrument that we use to pre-test and post-test short-term memory. So the dependent variable in our hypothesis could be operationally defined as short-term memory as measured by the internet alphabet recall test that we utilized within the class, and we could give the web address for that so that anybody else who wanted to do a pre and post with that measure could do so. That would operationally define it. So the hypothesis has to be testable. The independent variable and dependent variable have to be operationally defined. Ideally, the sample should be representative of the sample to which we want to generalize our results. A much better sample would be a random selection of students from classes in Antioch University. And if we were doing a bona fide research project, that is what we would want to do. Okay, so that's the first thing that I wanted to talk about this evening. I want to do a very quick review about measures of central tendency. Those are the three things that we covered last time. A measure of central tendency is simply an attempt to use one number to represent a data set. There are three measures of central tendency. The mean, which is the arithmetic average. Simply add all of the numbers together, divide by the number of points in the data set, and you have your mean. The mean is represented by the letter X with a bar over it, called X bar. That is normally the symbol for the mean of a sample. So let me erase this right here. X bar is the mean of a sample. In statistics, there is an annoying quality of using different symbols to express almost the exact same concept. The mean of a population is most often referred to by the lowercase mu, in the Greek alphabet. So mu in the Greek alphabet is the mean of a population. And you're going to find in many cases the symbol referring to the same concept, if it refers to a sample, will be different from the symbol that refers to the same concept, only in a population. Measures of central tendency: mean, median, and mode. You know the mean is the arithmetic average. The mode is the number that occurs most often in the data set. Sometimes there is no mode. Sometimes you have a multimodal distribution with 2 or 3 modes or more. And then median is the central point in the data set. You simply put your data points in order from the lowest to the highest and find the central number. If you have an odd number of data points, the central number will be sitting there all by itself. That is your median. However, if you have an even number of data points, there will be two numbers that are right in the middle. And in this case, you just simply add them together, divide by 2, you take the arithmetic average, and that becomes your median. Now, mean, median, and mode, measures of central tendency, attempts to represent a data set by utilizing one number. The mean is the best measure of central tendency if you have a symmetric distribution. The median is the best measure of central tendency if you have a skewed distribution, and I'll demonstrate what I mean by that here just shortly. The mode is simply the most frequently occurring data point in your data set. The formula for the mean is sigma x divided by n. And for those of you who weren't in class on our first class, this is uppercase sigma. That is the summation sign. And it simply means to add up whatever comes after it. In this case, you add all of the data points in the set, all of the x's, and then you simply divide this sum by the number of data points. This is called, or this is read, sigma x divided by n. And it's the formula for the mean, which could be expressed as x bar for a sample and mu if it were a population. Okay, we talked about standard deviation as well. And I'm going to go back to explain symmetrical distribution versus skewed distribution in just a second. Well, let me do that now, rather than go on to measures of dispersion, which is standard deviation. A symmetrical data set, if you have enough points and you were to graph it, excuse me, residual smoke bothering my lungs, I believe. If this is a normal distribution, and this is frequency of scores, that's the number of scores, and these are the raw scores here. This is the raw score. A lot of distributions are distributed normally. The normal distribution also has a fancy name. It's called the Gaussian distribution. And if you're ever on Who Wants to Be a Millionaire and they ask you, what's another name for the normal distribution? And you can say, Gaussian distribution, final answer. And win your $1 million, please send me a few bucks because I'm the one who taught you Gaussian distribution. Okay? Not really, but anyway, Gaussian distribution. If you have a symmetrical distribution, symmetrical simply means that if you were to fold the distribution upon itself, it would be the same from one side to the other. The left side is the mirror image of the right. Now, the mean is the best measure of central tendency in a symmetrical distribution. The mean is the best measure of central tendency in a symmetrical distribution. However, not all distributions are symmetrical. For instance, and the example that I use very often is about mean incomes in Montecito. And gosh, we had tragedies up there today with at least 8 people dying in their homes from the mudslides. It's devastation upon loss of home and loss of life, and it's really sad. But if you were to look at the distribution of incomes in Montecito or any other town that has many rather well-to-do people living in it, you would find that many people would fall around there, and then you would have your distribution pulled in the direction of outliers. And these outliers could be Ty Warner, they could be Oprah, making millions of dollars per year. And if you were to take all of the incomes in Montecito and average them, these two and any other outliers would skew the distribution. They pull the average in the direction of the tail. This is in the positive direction, and in this area it's the negative direction. If the tail of a skewed distribution is going off to the right, you call it positive skew. Positive skew. Whoops. Skew. Positive skew. Now, if you were to average all of these, you're going to find the average somewhere up in here. And let's just say that comes out to be 65. Well, let's just say it comes out to be 95K. This is all hypothetical, okay, but you get the picture that these two figures are going to inflate the mean, dragging it towards the direction of the skew. 95K is not a good representative number to represent the data set of all household incomes in Montecito. However, there is a measure of central tendency that reflects more of the truth, and that is the median. The median is going to be much closer over here, and I don't know what the median would be. I'm just going to take a guess and say it's about 65K. I don't really know what the figures are. They are available. We could find those out probably from a census. But in a skewed distribution, use the median as your best measure of central tendency. The mode, of course, is the most frequently occurring data point, and this is frequency here. So the most frequently occurring one is right here. This is your mode. So in a skewed distribution, you have mode, median, and mean stretched out like that, with median being the best measure of central tendency for a skewed distribution. And skew simply is something that is happens to a distribution when you have outliers on either direction. In this case, a couple of multi-billionaires, most likely, their figures being included in the distribution of incomes pulls the average in the direction of the tail to which it's skewed. So this is positive skew. The tail going in the other direction, if you had very low incomes, would be negative skew. So, to repeat, mean is the best measure of central tendency for a symmetrical distribution. Median is the best measure of central tendency for a skewed distribution, and mode, of course, is simply the most frequently occurring number in the data set. Okay, that is central tendency and skewed distributions. We also talked in our first class about the standard deviation, and the standard deviation is often expressed by lowercase sigma, which it looks like that, and the formula consists of this bracket, which is called a radical, which means find the square root of whatever is under here, and the formula is sigma, that's summation sign, okay, sum whatever comes after, and what you're going to do is do x minus the mean squared. So you have to do all of the operations within the parentheses first. So you make a table doing with every data point x minus the mean, and you square it, then you add these together. And the standard deviation for a population is divided by n. The standard deviation for a sample is divided by n minus 1. This is a difference I would like you to know. It is assumed that there's more variation, more deviation from the mean within a sample chosen from a larger population than in the grand population itself. And that's why they put this correction minus 1, because if you divide by a smaller number, your answer is going to be larger, okay? Larger standard deviation. This is the formula for the standard deviation for a sample, and this is the formula for a standard deviation of a population. We went through this our first evening in class. And one of the things that I wanted to point out to you, and I hope that you understand it, is that some of these formulas in statistics are just crazy long with all kinds of Greek figures in them. However, they are not difficult to do. What they are is tedious, extremely tedious, because you have to plug in every data point. So in showing you how we actually manually calculated the standard deviation, my trust is that you get an idea that some of these operations, although they look weird because they're expressed with Greek characters, are actually quite simple. And but you don't have to worry about manually calculating these formulas in this class, because we have these wonderful things called online calculators. We also have the statistics package for the social sciences, SPSS. In those, all you have to do is be aware of how to input your data points into the formulas and push a button, and the computer will do the calculations for you. So I would like you to be able to demonstrate using an online calculator to do descriptive statistics and a simple t-test, which we'll be covering later on. These are items that are on your statistical literacy checklist. All of those concepts I would like you to demonstrate mastery in personally to me, verbally, before class or after class or during the break, before the end of the quarter. The idea being that you exit this class with some understanding of the basic terms that are involved in statistics and some of the basic concepts involved in statistics. And I apologize, it's very dry memorization. The standard deviation is actually the average distance of every data point from the mean. It's the average distance of every data point from the mean. And when I ask you what the standard deviation is, I would like you to be able to give me that definition verbatim. Now, think of a cluster of demonstrators, example that I used in class, first class, in an intersection in downtown Berkeley. They're all tightly clustered together, blocking the intersection, and the standard deviation, the distance of every one of those protesters from the center, what we would call the mean or 0 point right in the middle, is going to be very small because they're all clustered in there shoulder to shoulder blocking traffic. That is a very low standard deviation, low average distance from the mean of every data point, which would be every protester. Now the police are getting upset with these people blocking the intersection. They've got the cavalry over on the side. They've got guys with the batons and the shields, face masks, ready to disperse. Oh my gosh, disperse. Remember that word. This is a measure of dispersion. Dispersion. The standard deviation is a measure of dispersion. Okay, so the police are getting a little bit upset, you know, hey, you guys, get out of the intersection. We need this traffic flowing through here. You're disrupting traffic. We need you to disperse. There's that word again, disperse. So, a very ambitious policeman who wants to court favor with his superiors takes a tear gas canister and tosses it, boom, right into the middle of the demonstration, and they scatter. They disperse. Okay, now you look at this demonstration with all of these people with the center point right in the middle of the intersection, and you look at the average distance of every demonstrator from the center point after the tear gas canister has been added to the mix, and you find that the average distance is much, much larger than it was before. Okay, the average distance of every protester from the center of that demonstration is much greater than it was before. Okay, that's dispersion. There are three measures of dispersion that I want you to be familiar with. My goodness, you have three measures of central tendency. You have the mean, median, and mode. And there are also three measures of dispersion, one of which is the standard deviation. It is probably the most often used measure of dispersion, but it is not the only one. If you take away the radical, you have what is called the variance. The variance is a measure of standard deviation. And so what is the relationship between the variance and the standard deviation? Well, it turns out that variance is equal to the standard deviation squared. Okay? And I'd like you to understand that relationship as well. This is the variance, and the calculation for the variance of a population. If it were the variance of a sample, what would we change? You'd add the -1. Okay, so this is the variance of a population. So the relationship between variance and standard deviation is if you square the standard deviation, bingo, you've got the variance. Now, that's two measures of dispersion. The variance is one that is used in many calculations in statistics, and that's the only reason that I presented here. Okay, now a very simple measure of dispersion is the range. The range is simply putting the data points in order from lowest to highest, the way that we did when we calculated the median. Put the data points in order from lowest to the highest. Then you simply subtract the lowest from the highest, and that is your range. So if your smallest data point is 1, and your data points go in order, okay, you would simply take 30 minus 1, and then you have the range. That is your range. You need to be able to define the range operationally for me and show me how you'd get it from a data set to satisfy that item on your statistical literacy worksheet. 3 measures of central tendency, mean, median, and mode. 3 measures of dispersion, standard deviation, variance, and range. Okay. Let's take a look at what else we've got in the book, and I do apologize that I have the 13th edition because the publisher sent the most recent one, even though I requested the 12th, and the 12th is the one that I asked you to get. I also have a copy of the 11th, and I noticed that in the first 2 chapters there's not a lot of difference between the 11th and the 13th. I'm hoping there's not a lot of difference between whatever edition you have and the 12th, and I do apologize for the mess up there. Most of the stuff that is in these first 2 chapters is pretty straightforward. There's several types of research mentioned. I'm not going to bother to go over that. You can read it. It's very straightforward. Chapter 2. Very straightforward stuff. And I wanted to see if types of knowing, ways of knowing things are included in chapter 1. I believe they are. Oh, there's a nice illustration of determining the causes of behavior on page 11 in the 13th edition. I hope that this illustration is in your book as well. It's causation of behavior. It's very straightforward. Ways of knowing. Yeah, there are several ways of knowing that are commonly practiced in human society, and one is intuition. Intuition, this is where somebody just has a gut feeling about something and they go with that gut feeling. Intuition, sometimes it works, sometimes it doesn't. Depends on how psychic you are. It's interesting trying to develop some psychic power. Through meditation, I've actually developed the potential to move physical objects with my mind, sometimes referred to as telekinesis. So watch carefully for a moment. Try not to be too skeptical of this, but I'm going to try to move something with my mind. Oh my gosh, I thought about my right hand going up, and it went up. Telekinesis. Okay, so you've heard that joke before. At any rate, um, intuition is one way of knowing, authority is another. Authority is simply taking someone's word, someone who is attributed with expertise in the subject that involved. If you're taking something from a textbook and citing it in a logical argument that you're making or as evidence, this is relying on authority. If you are quoting a professor from a class, if you're quoting Dr. Glasgow, that happens to be authority as well. Authority also has to do with things like, well, the imam told me that this is so, or the rabbi or the priest or various other religious leaders said it is so. And accepting the word of someone who is a leader in a religious domination or a faith is accepting something on authority. I know it's true because it's written in the Bible. That's taking something on authority. Okay, now there are other ways of knowing as well. And the one that we're going to be looking at is empiricism. Empiricism means observing something with your senses and then making some measurements, perhaps making some predictions about what will happen if you manipulate the things that you're seeing in a certain way. But empiricism is based on sensory perceived information. Okay, an example of sensory perceived information could be shoe size, very easily measured. Something that is not so obvious would be conservatism versus liberalism. This is not something that you can easily see or easily put a number on. It can be done, but it does not lend itself to empirical information. But shoe size does. So does height, so does weight, so does, for instance, reactivity of one substance with another. Dropping a little bit of pure sodium into water, you get a little fantastic spray of stuff, and you can measure that reaction, the amount of heat that's generated by it, etc. So know what intuition is, authority, and empiricism. Now, and empiricism has to do, of course, with the scientific method. And in research, that's what we use, is the scientific method. Scientific method is described in many places. You've probably studied it many times, but basically it means making observations, making a hypothesis or a guess based upon those observations, making a test utilizing what you have observed, measuring the results of that test, and then making some revisions to your hypothesis if you have to, or confirming that hypothesis. Okay? Now, with all of these things, intuition, authority, empiricism, and scientific method, there is something that is very healthy to have as well. And that is skepticism. Criticism that is based upon evidence that is gathered by the senses is good evidence for skepticism. Skepticism means looking at conclusions that others have made and wanting to verify how they got their results. In scientific study, verification is done by duplication of research. In order to duplicate research, the processes that have been used in whatever research study you're concerned with have to be very, very clearly delineated so that someone else could duplicate them. And believe me, for every article that is published, there are 10 people waiting in the wings to try and disprove that article by trying to duplicate the results. Sometimes duplication results in something being discredited, or perhaps shed some doubt upon, or confirmed. So skepticism is an excellent quality don't accept everything that you read, even if it appears to be scientifically correct. It is always good to view it with a degree of skepticism and trying to examine whether or not others have empirically come up with the same results or not. Whatever the results of our mock research project will be concerning the relationship between guided mindful meditation and short-term memory. And our hypothesis is that a certain number of sessions of guided mindful meditation as done by Dr. Galaska will improve short-term memory as demonstrated by a pre and post short-term memory test found at a certain website. And for those of you who weren't here last week, we did a short-term memory test, and we'll be using those results, comparing them with our post test later on to see if there will be a statistical relationship between our manipulation and our dependent variable, which is short-term memory. This particular research design is done with one group, you. Okay, you are a convenience sample. And we are comparing each member of our group with a pre-test, doing our intervention, and then a post-test. This is termed a within subjects design. That is what we have in our mock research project. We have a hypothesis with an independent and a dependent variable. We have our independent variable and dependent variable operationally defined, as I had mentioned earlier. We have our sample, which has weaknesses because it's a convenience sample that may make for difficulties in generalizing our results to a broader population. That's really all I wanted to discuss right now. I miss seeing you guys this evening, and I hope that all of you are safe and not in any danger from the mudslides and the runoff that we have with the rain. And I hope things get back to normal pretty quickly. So I will see you guys next week. If you have any questions, please email me. God bless you all. Miss you. I'll see you next week.